Okay, who has heard me speak before, besides up a canyon? Yeah, if you'll find me up a canyon quite often. I love to study nature and things, and it just gives me so much capacity to appreciate creation. It really does. But that's not what I'm going to talk about today specifically. I'm going to talk about more what is being taught in our schools. A little background on me. I have loved science since I was just a little tyke, and I grew up just really getting into science, even though I was challenged in spelling and those kinds of literature type things, which I still am. I really excelled in science, and I really enjoyed that aspect of learning. And I went to BYU, studied mechanical engineering, went out and started a computer concern, and then I've done some various things in life, but now I'm doing really focusing on some research. And it's been exciting. It's been like an adventure. Really it has. Really an adventure. So, again, I'm Vince Newmeyer. But let's talk about the science standards that we're talking about in schools. Now, I have one person who's seen a presentation of mine, and so this is going to be pretty much new for most of you. And we'll have hopefully a few more minutes to get to some more details. We'll see how it goes. Can someone, I had my timer here, but maybe someone could wave to me when it's about 10:02. Who would do that? You would do that? Okay. Yeah, wave to me when it's about 10:02, and then I'll take about 5 minutes to sum things up. And actually, why don't you wave to me when it's about 1:45, because we want some questions in here, okay? We want to be able to get some questions. When I walked in, they stuck a name tag on me, so I feel pretty prepared now. I know who I am. And so anyway, let's get into things here. So, our Utah science standards that are being proposed, the Common Core science standards, well, let's take a look at some of the evidence. Here is one particular science standard, and if you look at this science standard and compare it to the next generation science standard, it is word for word. Now you can do this exercise with every one of these standards that are given in these science standards. This is what they're handing parents now, and they say this is our science standards, and in here it has the performance expectations. Every one of these are word for word out of the next generation science standards. In fact, I was part of the parent review committee for science, which as of 2014, the legislature says we need to have a parent review committee that looks at these standards in more detail before they go out to the general public. And I was fortunate enough to be selected by the Senate to be one of the parents in that committee. There was 5 from the Senate, 5 from the House, and 7 from the State Office of Education. It really turned out to be mostly professors and science teachers and district science specialists. There were a few parents there with the parent's perspective as opposed to the administration perspective. So it was kind of interesting, but nonetheless, we made some waves in there. And this is what they gave us. Now this is only for 6th, 7th, and 8th grade. You see that big stack of papers? This is what they're handing the parents. And so what is missing? Well, if you go through all this material here, it's the rest of the next generation science standards for 6th, 7th, and 8th grade. And this really sets a precedence for adopting the entire next generation science standards. We're not talking about just 6th, 7th, and 8th grade. We're talking about material that they haven't even mentioned yet, that is intent on getting in there. And we'll talk more about that in just a second. Okay, so why is it called Utah Science Standards when it's clearly the Common Core or the Next Generation Science Standards? Well, we do have several people that were officially on the Next Generation Science drafting team. Brett Molding, who is actually one of the authors of our current science standards, along with some others. He was one of those people on the Next Generation Science Standards writing team, and Nicole Polson was the editor. Officially, that's all that is mentioned out of quite a number of people from all across the nation here. And further, if you read in the Next Generation Science Standards licensing agreement, it says states that have adopted or are in the process of adopting the Next Generation Science Standards in whole shall be exempt from this attribution and copyright provision of this license. In the material that they gave us in the Parent Review Committee, there was no mention at all of the Next Generation Science Standards. In fact, when the discussion was started to turn in our Parent Review Committee through this little email discussion we had going on, that they're about the Next Generation Science Standards, there are members of the committee who says, let's not talk about that. We're supposed to be talking about the Utah Science Standards. And I had to say, these are the Next Generation Science Standards, unequivocally. Okay, what's that other note there? Okay, so apparently there was an attempt for wholesale adoption of the Next Generation Science Standards, and not just this little piece that's being shown here. Okay, so I kind of mentioned that. So we're being shown grades 6 to 8, but the evidence shows that they really intend to adopt all grades, K through 12. Now, what about these standards that is so concerning? There's an independent organization called the Fordham Institute, and the Fordham Institute scored the Next Generation Science Standards with a C. Can anyone guess what our current Utah standards that are in place right now scored in the Fordham test? And these standards are you know, about 15 years old or so. What did they score? It was a B. Yep, exactly. It was a B. And labeled as clearly superior to the Next Generation Science Standards by the Fordham Institute. Well, so why do I say Common Core when Common Core clearly only covers language, arts, and mathematics? Well, let's dig into this a little bit more. In the discussion, will the new standards be this is from the Next Generation website. It says, will the new standards be the Common Core state standards for today? So they talk about how their effort was, just before this paragraph I have here, how their effort was to create a standard worthy of that. And then they mention this directly after that. It says, to reap the benefits of the science standards, states should adopt them in whole without alteration. States can use the Next Generation Science Standards as they are using the CCSS, or of course the Common Core, in English language arts, to align curriculum instruction and so forth. So yes, it is. It was designed from the ground up to be the science component for Common Core, the complement of it, even if it doesn't come under the same name. Now, there's been some very interesting discussion going on. How many have seen this YouTube video? A few of you. It's very, very revealing. What it does is it takes a number of state office officials and takes audio from quotes where they have been spoken on the record that they will never adopt a national standard. They will never do that for science and some of these other things. They say that over and over again. Sidney Dixon, Superintendent Menlove, and so forth. And then what are they doing? They're adopting a national standards. And not only that, they have been in the process of this for a very long time. So there is great duplicity in what is said and what is actually being done with certain members of the State Office of Education, I hate to say. So in these standards, we find some deficiencies. There's no computer science, but there's a great imbalance in various perspectives. For instance, climate is mentioned 58 times in the K through 12 documentation, where electric current, or current, just current, as in electric current, is mentioned only 3 times, only 3. Evolution, specifically mentioned, over 30 times, but there's a lot of other mentions as common ancestry and all this that bring that number way up as well. No human anatomy. I'm not going to go through all the details of this. We can discuss them more at another time. We just don't have enough time because there's some really cool stuff I want to show you. It's just so exciting. Okay, so Utah standards, national standards, what does it mean? How is Utah doing currently with our science standards that we have? Well, if you take a look at things, the ACT is actually ranking us very, very high in our science proficiency as we teach our students. Now, this is a great shock to a lot of people because they hear all this discussion about how Utah is just failing in our science standards. There's this big standard out there that we need to meet. Well, actually, we have scored #1 for several years. Now, I need to point out what this really means, because some states, like Utah, have compulsory, everyone takes the ACT. And that wasn't so until, I guess that changed in about 2013, okay? Or maybe 2012, somewhere around there, as we see 97% there. So anyway, but before then, there was fewer people in our state that took the ACT. And in some states, there's very few people that take the ACT. They use other measures for their tests. But those who do take the ACT, are they going to be the students that are usually dropping out of things, not doing so well? Or are they going to be the top students? Yeah, they're going to be the top students. They self-select themselves to take these other tests because they think it'll give them an advantage, that they'll show well in it. And so if you compare states that have similar, like 73 and above, here we're doing 100%, I considered 90% and above. If you compare similar states to similar states, Utah comes out #1 for the last several years. Three-way tie for #2. That's not a bad showing for this state, and I appreciate, and it's more than standards, of course. There's a lot of other things that go into making students proficient students, and I applaud teachers and parents and so forth in being able to make that. So, in these standards, it's very politicized in certain aspects. For those who were in some of the other classes just previous to this, I'm going to take that off. I'm going to be totally upside down in no time at all. Anyway, this politicized perspective is very powerful and really reinforced in these science standards. For example, talking about global warming and so forth, the clarification statement says, emphasis is on the major role that human activities play in causing the rise of global temperatures. Well, there's actually a lot of discussion that human activities have anything significant to do with that at all. And so they're pushing a paradigm rather than looking at things in a scientific way. Here's another issue on the global warming. Human activities are major factors in the current rise in Earth's mean surface temperature. It wasn't just a little while ago that I saw an article that came out about there's an investigation being opened up because of evidence of tampering with the data. And so maybe global warming actually is man-caused. Because they manipulated the data. Maybe that is, I don't know. Investigations will tell. But in this science review committee, the standard review committee, there was a professor who emphatically said evolution theory is just as solidly supported by data as gravitational theory or relativity theory. Well, let's take a look at that. And we're only going to be able to take a look at just a little onion peel of a great body of evidence, which I'd love to share with you. If you guys want to set up some more meetings for me to talk at sometime, I am happy to do so. I'm happy if my mom comes and to hear me speak sometime. And so I'm just thrilled that all of you folks here, people I don't even know, came to hear me speak. I appreciate you coming. But if you want to get something together, I would love to speak to someone and share in more depth about some of these things. Well, let's look at this detail in more detail. So here is Haeckel's embryos, and this is one of the things that they hold up as standards. Who has seen this in their science books in the past? Anyone? Maybe you don't recall it? Okay. Well, I'll tell you what it's supposed to show is there's a little phrase that's usually attached with this, which is ontogeny recapitulates phylogeny. Oh, those are a couple of big words. What do they really mean? Ontogeny, or the development of an organism, recapitulates, or goes through again, phylogeny, or the development, the evolutionary development of that organism. That was the idea that Haeckel proposed back in the 1800s. Very interesting like that. Now these are his actual drawings. Now he took drawings from actual one of my embryologists of the day, but he manipulated them. Some of them he copied right over, but he manipulated them in order to get the things to show what he wanted. In fact, if we look at the actual data, this top line here is Haeckel's drawings. This middle line here is the actual embryos at that same stage as they're developing. And you see there's actually quite a difference. And if you look in the microscopic data even earlier than this, there's even greater differences than that. Now that's a very interesting thing, and these science standards or the science books not always show Haeckel's drawings nowadays. Sometimes they show others, but the emphasis is still there when it's been shown to be absolutely false. Well, I kind of spoiled the secret here. Actually, in this discussion, one of these professors from this university actually says that I was really off base on my science and I need to get straightened out. And he says everyone needs to go to this website and get the real skinny on what what is really the truth. Well, I went to the website, and what did it say? Haeckel's theory was rotten to the core. It was both wrong in principle and in the set of biased, manipulated observations used to prop it up. It was a tragedy for science. Wow. I didn't expect that, but I'll take it. Yeah, I was being supported even by the sources that were said to correct my misunderstandings of science. But this theory is taught in one form or another, even in the science standards today. And they say don't go, specifically there's a boundary statement. They have boundary statements in these standards, even though they don't show them on the parent copy of things. They say don't go to the microscopic data. You know what? That's where the best stuff is. It's in the microscopic data, but they don't want you to go there. So why the critics of next generation standards are wrong? There was a paper that was written a while ago, and it was supposed to just really show how people like myself and so forth were really off base. And one of the things that's talked about is science is much more than just a body of knowledge. It's fundamentally about establishing lines of evidence and building these relationships to show science. Well, you know, that's interesting, but there's a fundamental aspect of science that is being totally ignored in everything I saw about these science standards. And that fundamental aspect is the ability to ask questions and to ask questions that which may falsify the data that, or the theory as it's proposed. For example, the NGSS does not encourage critical questions. They really don't. And they say, this is what you need to find. You know, they guide you into that conclusion. And this is especially true when you consider things like global warming and the evolutionary paradigm, which is the common ancestry of all life and purely material means for generating the complex structures, organisms, and systems that we have today. The idea of falsifiability I have not found at all in these standards to this point, and certainly not in the 6 to 8, and I haven't found them in some of the other things so far. There is, and really I've been focusing on a grade 6 to 8 because that's what they're promoting, right? That's what they're trying to say, this is what we're talking about. But anyway, if we don't have the idea or the concept of falsifiability, that is some method or way in which we can determine that something is false, then really the theory just becomes a paradigm or a mantra, a belief system that is used to promote a dogma, a philosophy, and so forth. If we only look at data that supports the theory, we're promoting a paradigm, not actual science. And this is exactly what we see in some of the discussion of the next generation science standards, and I encourage you to check it out and see. So, examples, Well, we already kind of talked about this. I've kind of combined a couple of different presentations. But here's the standard evolutionary paradigm of thinking, where we have this little spark of life somewhere, which then gradually changes and branches out with more and more complexity and sophistication as it goes up to the higher levels. And this may not be exactly true, but man came from the common ancestor of a chimpanzee. If that's a chimpanzee, that's really not a chimpanzee, at least not supposed to be. It's the common ancestor of the chimpanzee. That's what they say is the origin of man. And but today, do we really have that in the fossil record? Well, as it turns out, that today we have 26 animal phyla, or basic body plans, okay, of life, living today. I'm talking about of just the animals. And at one time there was discussion in looking at these very first blossom of life, as they call it, this Cambrian era in the strata. There was talk that there is over 100 different phyla, where today we have 26 basic body plans. They said it looks like there's got to be over 100 here. Now this was only in an aquatic environment. And so what was happening on land, they say nothing was. You know, maybe there's some discussion to be had there, but let's just go with their idea here. Just in that aquatic environment, which they claim is the very lowest basic level of life, the explosion of life, there was 26 different, or there's 26 today, but there was 23 in the Cambrian environment. Now this goes back and forth, and there's some discussion there. They had to combine a lot of those different phyla into the other phyla in order to come up with these smaller numbers, which were rather embarrassing for them. But nonetheless, it is generally recognized, or pretty much irrefuted, that there were vast varieties of life in the Cambrian. They say there were 3 different phyla that did exist before the Cambrian slightly, but we can start to discuss that in more detail. But the obvious evidence points to a sudden burst of life rather than a gradual evolution of life. Well, I'm not going to go into these details here because we've got to move along pretty fast. But this is something that was found in the biology textbook that my son and daughter used for their AP biology class. The theory of evolution, it said, has greatly influenced our way of thinking about ourselves. One reason is, of course, that it contradicts the literal interpretation of the Bible. Another difficulty is that it seems to diminish human significance. The new biology asks us to accept the proposition that we are not fundamentally different from other organisms, either in our origin or in our place in the natural world. Wow. You know what? I don't think that belongs in my child's textbook. That is a statement of philosophy and not a statement of scientific fact. It really doesn't belong there. And this is true in various areas where science tries to talk about origins, where they say there's this great evidence leading to some conclusion, but you look at the details and there are fundamental issues along the way. It's not a place where we just have a gap. A lot of times people like myself are accused that, well, you're just trying to push your intelligent designer or your God in the gaps that we don't have yet. Well, it's not just gaps. It's like the phyla in the Cambrian area. We have evidence of a great many more variety than should be expected. And on. I could name any number of things like that. There are fundamental issues that, with our current science, do not get us to the conclusion that science is trying to promote. Now, they say, well, someday we'll figure that out. Well, it's possible, but I think it's very much more probable, in my mind, if we're talking philosophy, that there are other explanations other than material causes to that. Well, anyway, so let's talk a little bit about what evolution is. Some people say, well, evolution is just change over time. You know what? I see change over time. I see living things change over time. I see evidence of inheritance and so forth. Do I believe in evolution? Yeah, in that sense, absolutely. I believe in evolution. I believe there are mutations and natural selection. I believe that. But this is not what the real issue was when we talked about these science standards. This was the real issue. This is the foundation of the Darwinian biological evolution, which is the common ancestry of all life and purely materialistic means for the observed existence of complex structures, systems, and organisms. That was the issue that this professor said was so finely defined and supported by data. Well, it's interesting to get to some of these conclusions. You have to go through certain philosophies which are trying to be pushed in science. Methodological materialism, which means no hidden forces, no influence from God, no angels or demons, no magic, no miracles. Now that's very interesting, where at the other side of the spectrum we have probably the greatest scientist that ever lived, Newton, in which he says, you know, he discovered gravity. He says, well, I have no need of God anymore. I know that there's gravity that holds these planets in their positions. No, he says that there must be a divine creator in order to put this together, because it could not come about through the laws of gravity. He actually studied theology much more than he studied science, and he often brought them in together to support one another. Well, that is absolutely ruled out in certainly our schools, our public schools, as it's usually promoted.
Excuse me, who is Stephen Peck?
Stephen Peck is a professor in the valley here.
Here, okay.
Not at this institution. It's BYU. Anyway, so Stephen Peck, according to him, science conclusions must be limited to strictly the action of matter and energy in the framework of chemistry and physics. Well, why do we have that kind of philosophy? You know, can science disprove God? No, science can't disprove God. That's recognized. Because in order to do so, you would have to be able to understand everything everywhere. Is God behind on the backside of the moon? Is he in a cave somewhere? You'd have to know everything everywhere. You cannot disprove God through science. Well, if you consider that aspect, might it be possible, though, to detect the influence of a designer or a creative intelligence? Well, they say, no, you can't really put God in a test tube. And with that, I would agree. You can't put God in the laboratory test tube. I believe there are other metaphysical type test tubes, if you will, that you can test for God on your own. But yeah, you can't put God in a laboratory test tube. But you know, we have things like the SETI project, the Search for Extraterrestrial Intelligence. They're looking for evidence of an intelligence in the radio signals that are coming from outside of Earth. Or when we have a crime scene, we send investigators, people trained in science, to take a look at evidence and to come up with the best explanation of, is this person, for example, died of natural causes? Or was there some nefarious entity that was involved here? Or if we look in our archaeology, are we looking for just signs of wind and erosion? Of course not. We're looking for the action of an intelligent being that manipulated the environment, that manipulated using perhaps physical laws, but manipulated things in a particular way. We can look down on the ground here and we can see just pebbles, or if we look really closely, what might we find? Maybe we would see this arrowhead sitting there. Well, why do we recognize that as something that was created by a person? Well, it has certain symmetry and structure that is unusual and would not likely be formed by wind and erosion or forces such as that, right? And further, we can see that there is obvious function that could be applied to that. Well, it has the low probability of natural cause, a specified complexity. If we look at the various hypotheses, you might say it's even self-evident. Now, take a look at the form of these rocks here. Now, the shape of those rocks, they are very unusual too, aren't they? Were those carved out? Or were they probably natural forces? Well, I and you would probably agree, yeah, it's natural forces there, right? Yeah. But what about this pile of rocks? Yeah, it's obvious, isn't it? Or what about this pile of rocks? We can detect design just because of its obvious, unusual, and specified complexity. Well, and what if we saw something like that? Is that just an odd nodule of iron that formed somewhere? Or do we say there was an intelligent being that somehow crafted that for some purpose, it appears? Or if we have gears intermeshing, just at the right distance, on an axle, rotating with a little motive force in which to make them all work, we'd say there is an intelligence behind that. It doesn't matter if these are wooden gears or made out of some other unusual material, if they're very large or extremely small. Take a look at the 20 microns. Look at the scale on that. These things are ultra miniature gears. Where would you find ultra miniature gears? What's that?
Yourselves.
That is an interesting thought. Most people wouldn't think so because why? It would show evidence of an intelligent designer, wouldn't it?
Well, cells are the coolest thing.
They are the coolest thing, that's right. But take a look. The Isis nymph, where do we find them? The back legs. Yes, this little critter has gears on its back legs. Now, why would you put gears on the back legs of a critter unless it's stamped underneath made in China? You know what? This is why. This little critter is blown up in a very large scale here, but this little critter is only 2 to 3 millimeters long. And in some of the scientific papers, one paper said it can leap with the force of 400 G's of gravity. Another paper said up to 700 G's of gravity. That's so far beyond what our fighter pilots can withstand, so far beyond what our astronauts can withstand. But this thing not only can withstand that force, but it is the rocket that takes them to that force. Isn't that amazing? Now, in a grasshopper, the grasshopper has little nerves that give impulses back to the brain and the control centers to get this thing to leap with some uniformity, to give it direction. But this little thing is so small, so fast, that nerve impulses and so forth would be too slow. What's the solution? Put gears on it. And I believe that's exactly what a creator did. It has a low natural probability, a specified complexity. Again, to me, this speaks of a creator. And Thomas Jefferson talked about this kind of evidence, how it was self-evident. And he says, I don't need to appeal to religion to know that there's a God. And by the way, don't be misled by those who say Jefferson was a deist or an atheist. No, read his words. It is clear beyond clear that he believed in a God that was involved in our daily activities. Anyway, he says, I don't need to turn to Revelation, the Bible or whatever. He says, it's apparent in all the things around me. I see it. But there are those today who say biology is the study of complicated things that give the appearance of having been designed for a purpose. Wow. Is it true that this is all just an illusion? Or is there some way that we can empirically measure or test to see if this is self-evident? Well, I need to go through this really fast because I don't have much more time. But let me just kind of bring it down to a couple of points. Michael Behe made a very interesting study about malaria. Now, why would someone study malaria? We want to help people, right? But it's a kind of a difficult thing to study. But malaria cells, or the plasmodia, as they're called, plasmodia cells, which cause malaria, there's tremendous numbers in a single infected individual, something like 1 trillion cells. And chloroquine, the drug that has been used to, yes?
It's a quarter cap. It's a quarter to the...
Oh, thank you. I appreciate that. I'm so zoned in here. Yeah. Okay, well, we'll have to move through this quickly, so thank you. So chloroquine, which is the drug that's been used to treat malaria for some decades here, has now become rather inefficient or ineffective in fighting malaria. And it's in independent colonies, there has arisen these malaria cells that are resistant to this drug. And certainly this shows that some interesting things are going on, that there's mutation and natural selection, or in this case more really artificial selection, right? But in our measurements we find that this happens in colonies of about, that have been comprised of about 10 to the 20th cells. Now that's a big number. Do you guys remember your scientific notation? That means the number 1 with 20 zeros after it. That takes a while to write them out, doesn't it? Yeah, it does. Yeah, those are big numbers. That's why we use that little shorthand there. Well, as they analyzed the DNA of these various colonies that had developed this resistance, there has been certain things become evident. But in all of these colonies, there have been at least 2 of these little rungs on the DNA, these alleles or nucleotides, nucleotides that have changed, okay? There's 2 of them that have changed in concert, apparently, from the data in order to create this resistance. Now that's a very interesting thing, because if there were a situation that would require something just twice as difficult, that is 4 of those little nucleotides to change, it would take an exponentially larger number of 10 to the 40th cells. Now we're getting to write a lot more zeros there. It's starting to be really tedious writing those zeros, right? Well, what does that really come to? You know, it turns out that that means there, in our understanding of things, and this is considering an old Earth, 4.6 billion years old, where life began about 3.5 billion years or so ago. That means that is believed to be a greater number than all bacteria cells that have existed since that time, since life appeared on Earth. Now that's a real challenge, isn't it, for the evolutionary theory? It really is. Now what does that really mean? 2 DNA changes? How do we get our minds around that? Well, that's equivalent to, in our computer speak, 4-bit changes, or in our numbers, a number between 1 and 16. That's a pretty small number, isn't it? That's a very small number. But what we're talking about is not any change on that DNA, it's specific, 2 specific changes. Well, let's kind of bring this back. 4 DNA changes, or 8-bit changes, meaning 1 byte, or a number between 1 and 256 in that same location on the DNA, a mutation of that size doesn't look like it's possible in evolutionary terms. So, moving along here, we find that there's all kinds of structures in the cell that plug together like Legos. Legos are amazing things. I played with them, probably you guys did at least some. Plug them together and they have an amazing shape and they stick together. Well, in the cell, we not only have complementary symmetry, but we have complementary chemistry such that things will just snap together. And we're really running short on time. But I'll try to really move through this in the next section here. So how many coordinated changes would it take to put gears on a bug? Well, let's take a look. Remember, we can do 4 bits, 8 bits, it's getting pretty dicey, maybe, maybe not. DNA is kind of like the design of life, right? Well, today we use computer-aided design, or describe things with computers, kind of like the DNA, the bits on the disk, you know? So how many bits would it take to describe intermeshing gears? Well, did a little experiment, and you know what? It takes about 1,600,000 bytes of information to describe a single gear, 1 gear. That's not going to do anybody any good, a single gear, right? Okay, so we got to put them into the little system here. Let's put 2 gears together, intermeshing. What does that take? That takes 3 million characters of information, 3 million bytes. These are bytes, not bits, that we were talking about earlier. So that's a lot of stuff. And remember, a byte usually represents just a single character. It can be described in fewer than 8 bits, but usually it's 8 bits. Like an A or a B. It doesn't describe even the basic shape of the letter though. It just means that there's a table in which you can look up using a number and get an equivalence. It doesn't describe the font, the style, the size, any of those things that we can describe in our computers today. So let's look at a comparison. Do we have any football fans in here? Who's a football fan? All right, what's the longest throw that's ever been achieved? All right, just take a guess.
Probably 80 yards, maybe.
That's pretty darn good. I heard someone gave pretty authoritatively a little bit longer number, but yeah, 80. Let's stretch it to 100 yards. Okay, that's pretty safe. That we can't really exceed that. At least we haven't, you know. And so, what does that mean if 2 changes on that DNA is equivalent to making that football throw of 100 yards? What's the equivalent of getting DNA to have intermeshing gears? What would that mean? Well, that would mean you'd be able to throw that football 8.6 times around the earth. You know, you put that in a straight line. We're not even on the same planet. Never mind that people can argue this or argue that, or that I haven't included some little detail. We're not even on the same planet. Now, I have spoken pretty boldly, and I think it ought to be spoken boldly. But in a public school classroom, maybe I would speak a little more tentatively. But nonetheless, the evidence is very clear, because in the cell, we have amazing complexity. We have little things that spin around like electric motors using a proton-ion flow. We have shafts, we have levers, we have cogs, and all kinds of amazing things with springs and so forth. On the right, we have little robots. This is inside a cell, inside your cells. Thousands of these things that take goods manufactured in one part of the cell, and using the little microtubule highways in the cell, using a postal address system, deliver those goods from one place to the place where they're needed to be used. And without these, you wouldn't exist. Without that, you wouldn't exist. Now, do you think it would take more than 8 bits to describe these things before they become something functional that natural selection could act upon? Absolutely. Absolutely. Yeah, it would take a lot more. Well, Michael Behe kind of sums this up, and we're going to have to stop here because we're just flat out of time. Oh, there's so much more I'd love to share with you. So much more. But he makes this observation. He says in science, he talks about this argument, talking about malaria and so forth. His studies of malaria. He says this is not an argument that Darwinism cannot make complex functional systems. It is an observation that it does not. And in science, observation beats theory every time. Now that's his assessment. It's an assessment which I tend to agree with. Other people may disagree, and that's fine. That's fine. They can disagree. They can disagree. But there's still some powerful things to be looked at. Now, Michael Behe's studies have been independently investigated and confirmed and written up in the mainstream scientific journal, Proceedings of the National Academy of Science. And so there, and this is just one instance of many more that I could bring in, but we're really out of time. We need to kind of stop there. So, are there any questions that I could field just briefly here? Okay, we don't even have time to sum up some of the next generation science stuff. In short, make your voice heard, get your neighbors involved, come to these meetings that the state is holding and our meetings beforehand. We talk about some of this stuff. And there are 2 meetings left. One up in Logan tonight, which I'm headed for after I get done here. And then there's another one next week, next Tuesday in Salt Lake. Yes?
Is it already like done deal they're adapting these new standards? There's anything else that we can do about it?
It's not a done deal.
Is it just 6th through 8th grade, or is it?
Well, it's setting the precedence for the whole thing. It really is. There may people say, no, we could change. No, if we do this, we're going down that road. Yeah. So but it's not a done deal. We have some formidable opposition. We're making progress, we're touching the minds and the hearts of the State Board of Education, and that's where the decision is going to be made. That is it.
And when will that be?
That'll be in about 60 days from now, roughly. It's a 90-day public review period. We've been in about 30 days or so of this. And so, yeah, that's what we're looking at. Yeah, okay, so any other questions? Yes?
What is the rationale that's used to go from requirements that are on a B level down to the C level? I mean, how do they defend that?
Well, and that's an interesting discussion. That is more than I have time to describe. You can read the Fordham report. It's available online, and it's about 90 pages long.
But how does the Board of Education?
How do they justify it?
Yeah.
Well, they justify it by the best minds. The most brightest people tell us that this is the thing that we really need, and that this is the greatest stuff. And it's got to be. It just must be misunderstanding of some unintelligent or uninformed people. That's how they do it.
also said the world was flat.
Yeah, that's right. That's right. The majority of scientists don't determine truth. Truth is independent of what the scientists say. And that should be our goal, is to find truth. And how can we find truth when we do things like we can only explain things in the sense of material causes, matter and energy acting with each other over eons of time. And that's all that there is. That's all. So, anyway, hey, thank you so much. I have really loved talking to you. Contact me anytime. I'd love to share more information with you.